The second forecasting technique that we want to look at is called exponential smoothing. In the moving average, our forecast was always based on the actual demand data. This changes in exponential smoothing. Here the forecast is based on the actual demand on the one hand, but on the other hand it is based on our latest forecast. Now, and this is now interesting because, as you should recognize, everything that went into the creation of our latest forecast, all the historical data that we used to produce this latest forecast, is contained in this forecast. Though we don't lose anything from the previous forecasts. Let's have a look at it in example, and again we use the data from the slide 16, which is this data, the 12 month demand history, and we use this in this example. We want to create a forecast for January, and we do this with a 6 months moving average from the data from slide 16, and then let's assume that the actual demand was 90 units. So the 80 has been calculated, and then we recognize that the actual demand is 90. This is observed by us. It's not calculated in any way. Now when we want to do the forecast for February, we can just calculate the average from the actual demand and the forecast. So 90 actual demand plus 80 the forecast divided by 2 to get the average. This is of course exactly the same like doing a weighting, an equal weighting between these two numbers, and a weighting of 50% for the actual demand and a weighting of 50% for the forecast, which in the case 1 would create a forecast of 85 units. So now of course we can change the weighting. This gives us a higher level of flexibility. For example, we can give the actual demand for January only a weighting of 10%, and the forecast for the month of January is weighted then by 90%. The sum of the weighting always needs to be 1 or 100%. So if we do this weighting, 10% for the actual demand, then the forecast for February is only 81 units. So with the same demand and forecast data, we can create different forecasts by having different weightings. If we generalize this, then we get to the exponential smoothing. In exponential smoothing, the new forecast is calculated by a weighting alpha of the latest demand plus 1 minus alpha multiplied by the previous forecast. This alpha, we call it a smoothing constant, and typically it is between a low number between 0.0 and 0.3. We multiply the latest demand with alpha and the previous forecast with 1 minus alpha, because to get our weighting of the total compound to 100%. So when you look at the picture, at the graph, there we have seen the straight line which gives us the actual demand, and we have two forecasts based on a smoothing constant of 0.1 with a dashed line, and the dotted line was using a smoothing constant of 0.3. Then you see that a higher alpha leads to a quicker reaction of the forecast to the actual demand development. Then the The actual information from the last period has a higher weight and the forecast adjusts quicker. When alpha is low, we put most of the weight to our forecast and we put little weight on the actual demand to correct our forecast. The exponential smoothing works well to update forecasts in situations where the demand is rather stable. If the demand is unstable or very low or follows a strong periodic pattern, then the exponential smoothing is not the best method to use. I brought you 2 more exercises on exponential smoothing, and I would like you to try to solve these exercises for yourself first and try to apply these methods to solve the exercises, and then we will later have a live session where we solve the exercises together. And for exercise number 3, we now include the moving average and compare it to 2 different exponential smoothings. You see that we have in the third column the 3 months moving average, and in the columns 4 and 5 we have the exponential smoothing. In column 4 we apply a smoothing constant of 10%, and in column 5 we apply a smoothing constant of 25%. And then you always should draw your results to compare the 3 different forecasts. And what you can see here, the actual demand has been drawn in blue. The red-orange one is the 3 months moving average, and we have the exponential smoothing for alpha of 10% and alpha of 25%, and how they react to the forecast and the actual data, of course. Let's sum up. Forecasts are extremely important for all planning activities in business and life, and of course for our production logistics course and creating production plans, they are of very high importance. We have different types of forecasts, quantitative or qualitative forecasts, and we have intrinsic or extrinsic forecasts. We introduced the moving average as a simple forecasting method based on past demand data, and we introduced the exponential smoothing that is using a smoothing constant, which is performing a weighting of the most recent demand and the latest forecast.